So, welcome everyone to my talk about time series with Apache Cassandra. My name is Michiel Smit. Already got some questions about that. That's a two-part last name. Looking at the future in this corporate shot. Luckily, there are also other photos available, obviously with the PHP elephant. I'm a backend developer. I work mostly in PHP. I also love working with Linux, databases like Cassandra, Node.js, AngularJS, etc. Last year, I came into contact with big data storage. A sensor project came in, a client who wanted to have us work on a portal in which he wanted to store millions or even billions of rows. And well, the start was very small. They only had a few customers, so only a few sensors that were communicating. But potentially, it was huge. We could end up with billions or maybe even trillions of records. So we started to look around. What databases could we use? And eventually we landed on Cassandra. Before I get into the whole Cassandra thing and everything that has to do with the time series, I wanted to show you this meme. Well, everyone probably knows this one. One does not simply store big data. And although this seems very legitimate, my goal for this talk is exactly the opposite. I want to show you how easy it is to start using Cassandra to store your big data, and in this case specifically for time series. What I hope you'll take away from this talk is that everything I will show you, that it's very easy to start using it, but that the difficult part is understanding how you should model your data. That's the important part here. So we'll spend a lot of time looking at what data we have and how we could model it so that Cassandra best understands it. A colleague of mine mentioned that at this point it would be a good idea to tell you or go over the definition of a time series. Maybe not everyone knows this. Well, a time series is simply a series of data points that is indexed by time. A couple of examples. Could have stock market data, weather reports, maybe sea levels, sensor data. Also, most of the time, these things come in at regular intervals. This is not a requirement, but often they arrive at regular intervals. One thing I won't talk about during this talk is installation. I could probably ramble on for an hour about how to download Cassandra, which install you need, how to configure your consistency levels throughout your cluster, etc. This is a bit boring. What I want to do is get you excited about Cassandra, show you what it can do, how easy it can be to work with. If I talk about installation, you'll probably not remember most of it. Plus, there's excellent documentation available online. What I will talk about, obviously, what Cassandra is. I will talk about how we model our data for Cassandra and how it stores our data. I will tell you what you should expect from it and what you should not expect from it. Like I said, we'll go into how Cassandra stores your data, especially for time series. Finally, I'll talk about the DataStax PHP Driver. This is a PHP driver that allows us to interact with our Cassandra cluster. So let's get into Cassandra. Well, first off, Cassandra is a distributed NoSQL storage. A couple of definitions for NoSQL. I think non-SQL was the first definition. I like the one not only SQL, and as we'll see for Cassandra, that's a really good description. Cassandra has its origins in Facebook. Back in 2007 or 2008, they wanted a database that could power their messaging inbox system. They wanted to search through it, and they had massive volumes of data, but they had problems searching through it. Internally, they developed Cassandra. Eventually, it didn't really work out for them. It wasn't the best database. They designed something that didn't really work for them. However, it was quickly picked up as an Apache project back in 2009, and it quickly became a well-maintained database used by very big companies like Apple and Netflix. DataStax is a company that you'll often encounter in the Cassandra world. This is a company that sells big data solutions. That is their business model, but they have a lot of good documentation online. They provide repositories for Cassandra distributions. You can download all sorts of things there. Really helpful. So what are the key features of Cassandra? Well, First off, it's decentralized for a lot of big data storage systems. But for Cassandra, every node has exactly the same role. There is no master, which for some people might be a bit disturbing at first, but you'll just have to get used to that one. This means that every node can perform any request that you do. You can ask any node to do a read or a write. Obviously, the cluster will communicate within itself to determine where the read should come from, maybe data stored somewhere else, but the whole thing manages itself. As in many big data storage systems, there is redundancy via replication. As we'll see during this presentation, your data is grouped together inside smaller packages, which are distributed throughout the cluster. You can define how this happens, and we'll get into that. There is a query language, CQL, Cassandra Query Language, and this looks a lot like SQL. This is really good for you guys because you can start using that right away. There are obviously some limitations because this is a different database, but it comes really in handy when you start using it. They also have a shell, CQL-SH, looks like this. There are a few graphical user interfaces available. I haven't used one myself yet, mostly because I haven't liked any of those that were available, and I like working like this. When you store a lot of big data, you're not going to have a lot of tables anyway, and when you do your database design, it's fun to work like this. What you should expect from Cassandra? Well, first off, a reliable and well-maintained database. Cassandra's been around for 8 years now. Doesn't sound too long, but it's really matured during that time. Again, companies like Apple and Netflix have thousands of nodes deployed. It works really well. It has a recognizable and easy-to-use query language, as we'll see later on. And finally, there's write performance that will scale nearly linearly. This is a test that Netflix ran just to prove how good Cassandra actually was. And as they kept adding nodes, the write performance increased linearly. What you should not expect from Cassandra? Well, what you should not expect when you first start using it is instant increases in performance. If you just have a couple of million rows, maybe you even want to relate those rows to each other, Cassandra, or maybe any other big data storage for that matter, is not suitable for you. If you're just starting out and you know your millions of rows will grow into billions of rows, that will be a better case for using Cassandra. Also, if you're used to running very flexible queries and you have data that you want to run these flexible queries on, perhaps Cassandra is not for you. For example, if you want to run questions like these, which any relational database will probably happily do for you, give me all the comments by user X on articles tagged with meme from June 2017 where you use the words cool or nice. Cassandra will be like, WTF. If you ask a simple question, like give me all the sensor data for sensor X in June 2016, your database will like that. This is an easy question which Cassandra is really good at and efficiently can answer. So, how does it do that? How does it store its data? Most important thing to realize is Cassandra is not schemaless. You need to define your columns. Other database systems like MongoDB, which is purely a document store, you can just inject your documents, your JSON documents, and it will happily store them for you. For Cassandra, you need to define your columns. This data is stored in rows. Well, that is something we're pretty much used to, and looks kind of like this in this example. Part of the data falls off there, but that's just a sensor identifier. As you can see, this is really recognizable. We have a couple of columns. These columns are probably defined in our table. What's important to realize, though, is you're not required to insert every column. Cassandra does not reserve space on disk if you do not fill a column. If you have 100 columns, you insert a row and only use 20, then no disk space is wasted. A very important and vital thing to know, once you insert data, data is grouped inside partitions. Let's get right into that, because what are these partitions? Partitions are simply groups of rows. And we will require a partition key to group the data. We need rules to tell the database these rows should belong together. These partitions are the parts that are divided among your cluster. If you have 10 nodes and you say I want a replication of 3, then each partition is replicated 3 times throughout the cluster. Sorting within each of these partitions is done in advance. You can imagine that if you have a billion rows and you wanted to sort on the fly when you do a select query, that would be very hard. So you define in advance how you want to get the data out. What you'll end up with is partitions with groups of rows. Just visually here, a partition is inserted into the cluster, or well, it's rather created inside the cluster and it's spread throughout the nodes. Cassandra does this all by itself. You have nothing to do with that. You only have to define the rules for partitioning. Let's look at an example. Here we have our example data again. The beginning column just has ABC for your information. Let's decide to group or partition on the location column. We would end up with just 2 partitions. We would have a partition for every row that is in warehouse 1, and we would have another partition that is in warehouse 2. We could also determine that we would need multiple columns to do this partitioning on. If we put everything in warehouse 1 or 2, we might end up with huge partitions. We could probably say that we want a partition for each day for each location. What's important to realize here is we do not have a day column right now. We only have a measured at column with a date timestamp. We would have to create this day, extra day column. Because during our table creation, as I'll show later on, you have to define which columns are used for the partitioning. If we'd use measured at right now, then we would end up with a partition for each unique second, which is probably way too much. One last thing, and very important, during each select, so every operation you run after you've inserted data, you need to define all of the columns you used in your partitioning. This is because the partitioning is central to how Cassandra works. If you leave out a certain thing, Cassandra won't know where to find your data. Having said all that, there are some limits to these partitions, and these limits are in place to make sure that Cassandra can keep operating efficiently. There's a hard limit. Probably we'll never reach that, but it's important to realize that there's a hard limit per partition of 2 billion cells, and that's rows times columns. So if you have 1 million rows inside your partition and they each have 10 columns, you only have 10 million cells, so you'll probably never reach that, but it's important to keep in mind. The generic advice out there is that you should keep them under 100,000 rows or 100 megabytes on disk. So what you end up with is all of these partitions that are in and around 100,000 rows. You can do less, you can do a little bit more, but this is generally the best advice. So how do we perform this partitioning? We use something called a compound key. And the compound key will determine what partitions are created and in what order they are sorted. The compound key consists of 2 things. The first part is the partition key, and the second part is the clustering key, or otherwise known as the sorting key. If we go back to our example, which we use the location column to create our partitions, we could say that we want our clustering key or our sorting key based on the measured at column. This is what our primary key would look like. The first part, again, location, will determine the partitioning. The second part will determine in what order the records will be stored. As you can see, I've used multiple columns here. You can do that. You can also say for the clustering you want multiple sort bys. The whole thing creates the unique primary key for your row. If I did not include the sensor, the only thing that would make it unique was the measured at column in combination with the location. So at the end, we first order by the measured at, and then we order by sensor. We can also define at the end if we want it ascending or descending. This really depends on your use case. You can imagine that if your use case is maybe generating graphs that run from January until December. Maybe you want the data ascending. But in most use cases, you want the data descending because you probably want the most recent data first. Before we get to an actual time series example, there's one thing I want to mention here. This is not the most important part to take away because it goes a bit into how Cassandra actually works and operates. But it's important to realize what happens behind the scenes. So when a write comes in, what happens? Well, first is written to commit log. That's something a lot of databases do. So in case your database crashes, there's a commit log that can be replayed. At the same time, it gets written to a mem table, also something a lot of databases do. Finally, every once in a while, data from this mem table is flushed to disk. All your data is stored inside something called SS tables, which is sorted string tables. These have nothing to do with your partitions. Inside these big files, these huge files on disk, multiple partitions can live. And Cassandra will know exactly where your partitions are in these files. Over time, these files are compacted. You'll probably have multiple SS files on disk, but they are compacted into a larger file. Visually, very simple actually. A write comes in, it's written to the commit log and the mem table at the same time, and then it's flushed to disk. And on these SS tables, the compaction happens. But why does this happen? And this is the important part. Cassandra does not perform updates in place. These SS tables are immutable. If your data is written, it can't be overwritten. You can obviously do updates, or you can do out-of-order inserts, but it is also always written to a new SS table. If you delete data, it's marked as a tombstone, it's not taken out of the file. And because of these things, compaction is periodically performed. The SS tables are rewritten, deleted data is merged out, maybe records are inserted in a better place, and it all does this automatically. This goes a bit beyond what I wanted to show you for this presentation, but it's important to realize that there are different strategies for doing this compaction. The default settings is the one on the left that works really well for most use cases, but there are several things. So if you're going to install your Cassandra cluster or start using it, read up on compaction. It's important to realize what's happening. So now that we've heard all this, what are the effects on using Cassandra? Design time is extremely important for any database for that matter, but especially in Cassandra's case. You can't just go back, change your table, and expect everything to be better. You need to think really well about how your data, how you want to store your data. How often is your data going to arrive? In what order do I want to get my data out of my cluster? May seem a bit daunting at first, like am I going to make the wrong choice and have problems later on? There's always things you can do, and you can always try to alter your table, but it's really important that you think about what you want to do with your data before you start doing it. So let's get to our time series, because we've talked about Cassandra in general, but this talk was called Time Series with Cassandra. Because considering all the previous, Cassandra seems really well suited for running time series. And why is that? Well, with time series, there's often a focus on writes. Especially with sensor data, we're probably writing way much more things than we want to read out. And Cassandra is really good at writing. It has a quick write path, especially considering the distributed nature of the database. The data in time series is often very well defined. Because Cassandra is not schemaless, it's really well suited for sensor data that arrives and you know exactly which columns you need to fill. Also, the data arrives at semi-regular intervals for time series data, which is very handy because when we're deciding which partitions we want to create, we can estimate how large they'll get and create a good strategy for saving our data. So let's get into an example. I'm going to show you quite a simple example with sensor data. We'll imagine that we have a situation where we have sensors that report just three things. We have a unique identifier for the sensor. We have a date time of the measurement that the sensor made, and we'll have a temperature reading, which just looks like this. Where do we start? Well, let's first consider the data that we're saving so we can decide on our columns and how we want our partitions to be made. First, we have to define our columns as in any ordinary relational database. Cassandra has column types. We have floats, integers, texts, blobs, etc. So we can just decide what our column should be. Very easy. Our device ID is probably an integer, as we can see. Our event datetime is a timestamp. Cassandra will accept a lot of datetime strings, but internally it will convert to a Unix timestamp. The temperature in this case is a float. Well, that's it for our columns. Now we just have to decide what a good partition for all this data would be. Again, let's consider what we have. We're taking measurements every 5 minutes, so that's 288 measurements a day, or about 100,000 rows a year. Well, remember the limit that we set? It was right about 100,000, so maybe a good partition would be per sensor per year. We would end up with partitions for each sensor for each year. In order to make the year part of this partitioning, we require that column, so we have to add the year column. The only thing left to decide now is how we want to retrieve the data. Again, pretty easy. We would prefer to have the most recent data first. If we're going to ask questions to our cluster, we probably want to ask what temperature it is right now. If we're going to do a select, we could ask, give me a record for sensor 9001 for the year 2017, limit 1, so we'll get the most recent record. We want that in that case. Our primary key would look like this. Really not that complex, right? We'll partition on the device ID and the event year, and we'll cluster on the event datetime. And we'll end off with the clustering order for descending. So every record that comes in is inserted on top. The full create table CQL looks like this. Well, a bit. Pretty recognizable for anyone who's worked with SQL. So that's it. We have a very simple example, but that's all you need to do to start using Cassandra for storing data like that. We've evaluated what data we have, we've created some columns, we set what our partitioning should be, and we created it inside our cluster. We can start inserting and retrieving this data. And for that, we use the DataStax PHP Driver. As I've mentioned, DataStax is a company that sells big data solutions, but they also create a lot of resources for the community. They have a GitHub with tons of resources on it. They have libraries for PHP, for Node.js, Python, etc. And these libraries extend your base installation with extra functions to connect to a Cassandra cluster. Again, I'm not going to spend time on telling you how to install it. There's plenty of tutorials online. Sometimes you can use your package manager to install it if your OS supports it, but you may have to read up on this. There's also some bundles available for Symfony, for example. Haven't really used this one, but this is the one that's best maintained. This is also a good bundle. It's a stub bundle which your IDE can use, so it detects all these new functions that the PHP library adds. Let's look at a few examples with this PHP driver. Well, just fits barely. With this example, we connect to our cluster. All we have to do is mention a contact point. Again, this can be any node in your Cassandra cluster. Maybe you've decided that you want some nodes to be contact nodes, but you're free to contact any node. Well, you define the port, your credentials. Very important parameter is use persistent sessions. The PHP instance or thread that it's running on will then cache the connection, so the next time you do an operation on your cluster, it won't have the startup time that it usually has. Finally, we use this cluster to connect to something called a key space, or which is pretty much a database. You have a database, and inside the database live tables. So we're connecting to the key space sensor data. And we can start using our cluster. We want to insert data. In the first part of this example, we'll prepare our query. We have a basic insert query with all the columns that we defined earlier. And we're just going to fill the values. In the middle part, we just create 3 example data, parts of data. I've used some of the Cassandra classes that are available to create the types that Cassandra expects. This is not necessary in every case. For example, the float, if you put an actual float in there, like a PHP float, or actually a double because PHP only has doubles, it will probably recognize it and convert it automatically. The same for the timestamp. I'm just doing it here for clarity, so Cassandra has no doubt about what it's receiving. Finally, we loop over these 3 measurements. We run the query, and as our arguments, we just give the values that we have. The same story for retrieving data. We have a very basic query. We supply some arguments, in this case our sensor ID and the year we want our data from. We create a simple statement, in this case we insert our query, and then we just get out our data. We have 2 options for doing this. There is an asynchronous call. You can use that to prepare multiple queries, especially if these queries take a bit longer. You can prepare these, loop over the queries, give them to your cluster, and maybe your PHP instance can do something else while it waits for the answers from the cluster. If you don't need that, you can just execute your queries directly and wait for the results. Again, that's it. That's all that's needed to start using your Cassandra cluster. So in summary, what do we have here? Well, what I hope you understand now is that you can start using Cassandra even if your amount of data is yet small. We've seen that the query language is really understandable. We've seen that the table design is peanuts. And if you have a use case that might have a lot of data or might grow into a lot of data, you can start using Cassandra right now. The only thing you'll have to do is think really well about what data you want to store and how you want to get your data out of the cluster. How do you want to use your data afterwards? So designing good partitions is central to using Cassandra. If you want Cassandra to store your data effectively, you need to think about how big your chunks of data are going to be. But after you do this, using the PHP library is a piece of cake. In closing, I would like to thank you for attending. It's been an honor presenting to you for the first time. And I would love some comments on my joined-in talk. And if there are any questions, I'll gladly take them. Thank you.